Okay, November 2018, paper 6, variant 1. Question 1. Student is determining the spring constant K of a spring by two methods. Okay. Method 1, he will measure the length, the original length of this spring. So what do we need to do? We need to measure the length from the dotted lines, okay, the distance between these two dotted lines. If we use the ruler to measure the distance between these dotted lines, um, it should be around, if you printed the paper, it should be around 21 millimeters or 2.1 centimeters, which is 21 millimeters. So in the answer, we should write down 21 millimeters. In the marking scheme, it could be a bit different. Why? Because when you print the paper, it would be scaled down a little bit, just a little bit. So in the marking scheme, if it's 22 and your answer is 21, it's not really a big difference. Okay, so this is the answer if you measure the distance between these two dotted lines. Not the whole spring, you just measure the distance between these two dotted lines. 21 millimeters. Okay, now he added a mass of 300 grams to the spring. What happens to the spring? It extends, and the new length is 53 millimeters. Okay. Question is, can you find the extension? And you have the equation. Yes, extension is L minus L naught. Where is L? L is 53. What about L naught? L naught is 21. So 53 minus 21. Yalla, 53 minus 21 is 32 millimeters. So this is the extension E. This is the extension E. Can I find K? Yes, I can find K. F over E, where F is 3 newtons, so F is 3 over 32. Can I calculate it? Yes, it would be around 0.094. K, the Spring's constant is now 3 over 32, which is 0.094. And that's it. It's as easy as that. Okay, so the questions are as easy as that, Ishweb. Okay, please, if you have any questions, type them. Okay. What is K? Again, K is the spring constant. Okay. What is K? K is the spring constant. Again, he is measuring the spring's constant. Okay. All he did, all he did was measure the initial length, and you measured the initial length using the ruler. When I measured the initial length using the ruler, it was 2.1 centimeters, which is 21 millimeters. 21 millimeters. So I just wrote down 21 millimeters. This is L note, the initial length. And then, okay, and then he found that the L was when he extended the length, the extended length was 53. Type E, the extension is now 53 minus 21. Okay, 53 minus 21 is 32 millimeters, and he found K. I don't care what is K. Even if you don't know what is the spring's constant, I don't care. Honestly, it doesn't really matter. Okay, it doesn't really matter if you don't know what is K, what is the spring's constant. It doesn't matter. Okay, so now I wrote down 0.094. Okay, the 3 was given. The 3 was given. Can I measure the time, or can I take the time? Can I read the stopwatch? Yes, you can read the stopwatch. The stopwatch, the timing on the stopwatch is what? The timing on the stopwatch is 3.46 seconds. Is it that easy? Yes, it's that easy. Okay, this is the time taken on the stopwatch. Calculate the time taken or the period of one oscillation. The time for one complete oscillation. T was the time for 10 complete oscillations. For 10 complete oscillations. Can I find the time for only one oscillation? Yes, I can find the time. Divide by 10. So 3.46 divided by 10 is 0.346 seconds. 0.346 seconds. That's it. طيب, Can I find t squared? Yeah, mister, what's t squared? T squared is just the period squared. Using your calculator, 0.346. Why didn't we take 3.46? Because he said period, the capital T, huh? Capital T squared. That's why I need to read the questions very carefully in paper 6. You need to read the questions very carefully. Now he wants T squared. Okay, actually, capital T squared. 0.346 squared, using your calculator, would be around 0.119. Too many numbers, so I can just write them as 0.12. 0.12. طيب, what is the unit for t squared? What is the unit for t squared? What did I do? I squared the time, and the unit of the time was seconds. So time squared would be s squared. Seconds squared. Seconds squared. Okay, calculate the spring constant K using this equation. K equals 0.04 m over t squared, where m is 0.3. Where m is a is 0.3. طيب, K is 0.04 m over t squared. طيب, do I have the m? Yes, I have the m. Do I have t squared? Yes, I have t squared. I have t squared. طيب, let's just plug in the numbers. 0.04 times m, which is 0.3. طيب, 3 Mr. طب it's 0.300. Should I write it down as 300? It doesn't really matter. It doesn't matter. Huh? Over t squared. What's t squared? 0.12 over 0.12. The answer would be, if you use your calculator, it would be 0.1. خلاص, 0.1. That's the answer. Okay. Why did I multiply? Because it's 0.04 m. 0.04 times m. 0.04 times m. So you need to multiply by whatever the value of m is. Okay, m is the mass, 0.3 kilograms. خلاص, يبقى you multiplied and you found the answer. Okay, and you found the answer. That's it. So now we have another value for k. Now you have another value of k. What is the value of k? والله 0.1. طب what was the initial value of k? What was the initial value of k? It was 0.094. So we have two values for k. 0.094 and 0.1. 0.094 and 0.1. Next question, he would ask you, are these two values the same or not? Are they equal or not? Are they equal or not? طيب, how do we know يا مستر? How do we know if they are equal or not? والله, we will use the percentage error. Do you remember how can we find the percentage error or the percentage difference? Okay, the whole point of the are they within the limits of experimental accuracy or not? How did we do that? We simply divided the larger number by the smaller number. The larger number would be 0.1. That we have two values for k, 0.1 and 0.094. So 0.1 divided by 0.094. If you use your calculator, 0.1 divided by 0.094, this would be 1.06. 1.06, which is 1.06, which means this is a 6% difference. A 6% difference. طب, is 6% يعني is it a lot? Is it within the limits of experimental accuracy, or does it exceed the limits of experimental accuracy? No, actually, it is within the limits of experimental accuracy. I told you the limits of experimental accuracy are up to 15%. صح? How do I know it's 6%? Because it's 1.06. You take the first two numbers after the decimal point. The first two numbers after the decimal point. 0.06. 06, this means 6%. 6%. Oh, this is within the limits of experimental accuracy. Yeah, but the statement, are they equal or not? Statement, yes. Okay. They are the same value. The same value. طيب, the explanation, you should say The numbers or the values are close. Oh, the are hmm, values are close within within the limits within the limits of experimental accuracy. Okay, of experimental accuracy. يبقى they are within the limits. Why? Because the percentage is less than 15%. If it's less than 15%, then okay, it is acceptable. Then it is acceptable. Okay. A student um, states that repeating method 1 with different masses would improve the reliability of the uh, obtained value of k. I need to repeat the experiment using different masses. Using different masses. What was the initial mass? What was the initial mass? If you go back, you'd find that the initial mass was what? 300 grams. That's why I told you need to read the questions carefully. You need to read the questions carefully. The initial mass was 300 grams. Okay. طيب 300 grams, I need to take more values. I need to repeat the experiment with more values. You need to repeat the experiment with more values. How can we repeat the experiment with more values? Well, if it's 300 grams, can I increase the values a bit? Yes. For example, I can take 350 grams. I can take 400 grams, 450 grams. Can I take can I go back and مثلا for example if it's 300 can I take 250 grams? Yes. What about 200? Okay. 150 would that be okay? Yes, it would be okay. So basically we're repeating the experiment using different values of the mass in order to find if to determine whether the value of k that we have calculated would be the same or not. That's it. That's it. That's all you need to do. Okay. So we repeat the experiment using different masses. Should the masses be huge? For example, it was 300 grams. Can I take, for example, 1000 grams or 900 grams or whatever? No. You can't take too much. You can't increase the number too much. We will increase the number. We will increase the number. It's 300. I will increase 50 grams and then 50 and then 50 grams. Okay. Up to what? Up to, let's say, 500 or 600 grams maximum. Up to 500. But if I decrease the number back to 50 grams, for example, but that's the minimum. Don't go saying, well, I will use a mass of 2 grams or 3 grams or 5 grams. That would definitely be wrong. Okay, so for this question you need to write down at least how many numbers, at least 4 or 5 numbers, at least 4 or 5 values. Okay, and the values should be within a certain range. Okay, not just any values. Don't just write down whatever numbers. Like, if you need to write down numbers, or if you write down numbers, you will write them with differences, with equal differences. Okay, with equal differences. I keep on increasing. I keep on incrementing the numbers 50 grams each number. I increase the number by 50 grams. So that's okay. Okay, so that is okay. طيب يلا. Moving on to next question. There was a question 0.094. 0.094 was the first value of the k. Okay, first value of k, and then 1 was the second value. 0.1 was the second value of k. Okay, yeah. We divided them to find the percentage error. To find the percentage error. Yeah. Record the current I as shown in the ammeter. Where is the ammeter? Oh, this is the ammeter, figure 2.2. The current هنا is 0.4 42 44 46 48, so 0.48 amperes. It's not 0.44. Why? Because this is 0.5. This is 0.5. يبقى 0.48 amperes. This one places the slide in contact at C. Okay, so C هنا is at a distance of, length is distance of 20 centimeters. And he takes the reading from the voltmeter. record the voltmeter reading. Record the voltmeter reading in the table in the next page. Record the voltmeter reading in the table in the next page. The voltmeter هنا 0. This is 0.5. It's exactly in the middle. Okay, 0.5. Why is it 0? Why is the current 0.48? يا شباب 0.4, 0.42, 44, 46, 48. Okay, 48. And then the voltage هنا is 0.5 volts, and we need to write down the voltage in the table on the next page. 0.5 volts. The student repeats the procedure for lengths of 40, 60, 80, and 100. The readings are shown in the table. Complete the column headings. Complete the column headings. The heading length L. What is the unit of L? What is the يا مستر L centimeters centimeters خلاص يبقى the length is in centimeters. What about the voltage? It's in V volts. Voltage ها volts. طيب plot a graph. Actually you can copy it from part D. V slash V, you can write down V slash V, and L slash centimeters, so you can just write them down. V slash V on the y-axis. So first of all, you need to label the axes, V slash V, and the x-axis, L slash centimeters. Okay, this is the first mark. 4 marks. First mark is to just label L slash centimeters. Okay, to just label the axes. And then he said, start both axes at the origin. Okay, I will start both axes at the origin. Type 0 and 0. Yeah, we need to put down numbers. Voltage would be 0.5, 0.9, and 1.6. Definitely, we cannot write down these exact numbers. We could write down 0, 0.5, 1.0, 1.5, 2.0, 2.5. Okay, 0.5, 1, 1.5, 2, 2.5. Keep on increasing by 0.5. What about the length? What about the length? We can increase the length. We can just write them down as they are. Okay, 20, 40, 60, 80. Hell, 20, 40, 60, 80, 100. Yeah. Okay. Yeah. Let's plot the numbers. Let's plot the numbers. Small x's on the graph. Small x's on the graph. Do not put small points. We need to put small x's on the graph. First number was 20 and 0.5. Yeah. This is a small x. Yeah. 20 and 0.5. 40 and 0.9. 40 and 0.9, which is 2 squares beneath 1. Okay, 2 squares below 1. 2 squares below. Yeah, 2 squares. Type 60 and 1.6. 1.6 is 2 squares above 1.5. 2 squares above 1.5. Type 80 and 2.0. Yalla. 80 and 2.0, and last but not least 102.4, which is 2 squares below 2.5. Yeah, 2 squares below 2.5. We have a very uh, nice graph. Actually, this would be a very nice graph when you draw the line of best fit. Okay, it would be very accurate. Let me use a straight line here. This is the straight line. Okay, if you draw the line of best fit, it would go something like this. It's going only through 2 points. Only through 2 points. ماشي. And 2 of the points are above. Hold on, let me draw it again. Okay, it's going only through 2 points. 2 of the points are below the line, and only 1 point is above, which is okay. This is definitely correct. This is definitely correct. يلا. Let me draw it again on this graph. يلا. طبعا this is using ruler يا شباب. It goes without saying. You have to draw this using your ruler. We do not join the points. Okay, you are not joining the points. You're just drawing a straight line, which is going through most of the points, or it could go through at only 1 point. It doesn't matter at all. What matters is that that you don't have too many points very far away from the line. These points are quite close to the line, which means that this is a best fit line. This is a best fit line. That, let me remove this line. Okay. Next question, he's asking, he wants to find the gradient. How can I find the gradient? How can I find the gradient? Using the rise over run method or the triangle method. Rise over run or the triangle method. The triangle method you have to draw on the graph. You must draw on the graph. Okay, let's join the furthest 2 points. Yeah, the furthest 2 points. You have to join them, شباب, using a triangle, and then you can use the rise over run method. Okay, you have to join these 2 points. If you do not join them, it would be wrong. You will lose a mark. You will lose a mark. The gradient, can I use the numbers from the table, or should I use the numbers from the graph? يعني the numbers from the table or the numbers from the graph. For example, this point has a y of 0.5 and an x of 20. This point, it should be 2.5 and 100. Should I use these numbers, or should I use the numbers from the table, which were 2.4 and 100? It wouldn't really differ. Okay, it would be the same. Not the same, very close, which is okay, which is acceptable. Okay, they are acceptable. But what if you didn't take these 2 points? What if, for example, you took these 2 points? For example, if you took these 2 points, would it be correct? No, it would be wrong. Okay, it would be wrong. If you take these 2 points, it would be wrong. Why? Because they are quite close together. They're very close together. You need to take two very far away points, and then we will. You will draw the triangle, you will draw, okay, rise of run, and then you will calculate y2 minus y1 over x2 minus x1. يعني again, oh, let me write it down. Y2 minus y1 over x2 minus x1. But you cannot just write down y2 minus y1 over x2 minus x1. That would be wrong. You have to draw on the graph, okay, the triangle method. I have to, as an example, I have to see y2 minus y1 over x2 minus x1. Okay, can I take 20, 0.5, 80, and 2? Yes, you can. Yes, you can take these 2 points. Okay, yeah, I will use these 2 points, which are 20. Yeah, let me write down the numbers. Let me write down the values. 2.5 minus 0.5 over 100 minus 20 over 100. طب يا مستر أنا I wrote down 2.4 minus 0.5 over 100 minus 20. Is that wrong? لا, that would be correct. Okay, yeah, let's calculate it. 2.5 over which would be 0.025. This would be 0.025. Okay, if you used 2.4 minus 0.5, it would be slightly less, which is okay. This is 0.025. Okay, the other one would be, I guess, around 0.023 or 0.024, which is again acceptable. Acceptable. Okay. But then you must draw on on the graph. You have to draw the triangle method. Can I calculate R? Can you calculate R? Yes, we can calculate R. R, you have everything. خلي بالكوا, you have everything. R equals GK over I, where K is 1. G, طب where is G? I have G. يبقى 0.024 times K, which is 1, over I. ايه ده, we don't have I. لا, you do have I. Okay, you do have I. Where is I? It was the initial current reading which we wrote down هنا, which was 0.48. It was the initial current reading. Okay, يلا, over 0.048. Okay, not 0.48, 0.48, 0.48, which is, I guess, 0.05. صح, 0.05. What is the, okay, what is the value, what, sorry, is the unit of the resistance? What is the unit of the resistance? Calculate the resistance R. Unit of the resistance is ohms. Unit of the resistance is ohms. يبقى okay. خلاص يبقى easy. Okay. شباب if g is 0.025 ولا 0.024 or 0.023 whatever, it doesn't matter, it is correct. Okay, it is okay. يلا next question. ray trace sheet. ray trace sheet. بص يا شباب دلوقتي this question you have to open up the next page next to it. You need to open up the book, okay? These two pages next to each other. Why? Because we will keep on reading, okay, the points and just doing whatever he's telling me to do. Okay, for example, on figure 3.1, draw normal NL. I will draw a line, normal line, NL, I will name it NL, at the center of side AB. At the center of side AB. At the center of side AB. Continue the normal so that it passes through side CD. Yani, I will start from the top, okay, from AB at the center of AB and draw the normal until it extends beyond side CD. The point at which it crosses AB will be F. The point at which it crosses CD would be called G. طيب واحدة واحدة. At the center of AB. Where is the center of AB? طب how can I find the center of AB? Just measure AB. Just measure, simply, let me zoom out. Huh? Just simply measure AB. I think if you measure AB, it would be around 8 centimeters or 8.4 centimeters. I guess AB was around 8.4 centimeters or 8.3 centimeters. Again, doesn't really matter. The difference between them, or the center of AB, would be at around 4.1 or 4.2 centimeters. Just measure the distance, 4.1 centimeters, which would be around here, and then draw the normal line which extends above AB. Normal line, a dashed line, okay, above AB and below CD. And below CD. And then name this normal NL. He said the line is called what? Is called NL. So just write down NL, normal line. حلو. This is the first point. Second point, the point at which it intersects AB. At which it intersects AB. This point is called A. This point is called F. The point at which it intersects CD. This is called This is called G. خلي بالكم يا شباب, while drawing these lines, you have to use a very thin pencil. Okay, you have to sharpen your pencil. You have to make sure that this normal is perpendicular. If the normal is not perpendicular, if it's slanted, okay, if it has whatever angle, if the angle isn't exactly 90 degrees, if this normal isn't exactly 90 degrees, then most of the readings, the next, now we will go on with this question, okay, most of your readings will be wrong. Most of your readings will be wrong. So please draw this normal very carefully. Make sure it's exactly 90 degrees. Make sure that this normal is exactly at the center of AB and exactly at the center of CD. Okay, make sure that it's exactly at the center of AB and CD, and then draw the normal with a thin pencil. With a thin pencil. Okay, but this is the normal, and L, point F, point G. خلاص, yes, that's it. Next point. He's telling me to draw another line, EF. Draw a line EF at an angle of 30 degrees to the left of the normal above side AB. Above side AB. To the left, left of the normal at an angle of 30 degrees. I will name this line EF. طيب. Let's go. Above AB, فين above AB? To the left of the normal at an angle of 30 degrees. طيب, يعني using our protractors. This is my protractor, okay? Your protractor should be placed somewhat like this and measure an angle of 0, 10, 20, 30 degrees. Draw a line EF. Okay, drawing a line EF. Yeah. This is the line EF. طبعا this line using a ruler, okay, goes without saying. This line is using the ruler. Line EF. Yeah, line EF. Yeah. This is line EF. Above the normal, to the left, sorry, above AB, to the left of the normal, at an angle of 30 degrees. خلاص, I drew the line EF. خلاص, he said E all the way to F. Okay. ماشي, يلا EF. Next question, he's asking me to uh, place two pins, P1 and P2. The positions of pins P1 and P2 on line EF. On line EF at the suitable distance. I told you the suitable distance between any two pins should be at least how many centimeters? At least 5 centimeters. صح? At least 5 centimeters. Okay? Should I write the angle inside? No, you don't need to write the angle inside. You do not need to write the angle inside. Okay, طيب يلا let's place pins P1 and P2 on the line EF. فين line EF? Pins P1 and P2, just small X's. يلا P1 and P2 as far away as possible. Okay, at least 5 centimeters. P1 and P2. بس. Easy. طيب P1 and P2 5 centimeters apart. خلاص, that's it. Yes, that's it. طيب, moving on to the next question. He keeps on talking a bit about how that light is passing. Then he places two pins P3 and P4. Okay, the images of P1 and P2 are seen through the block. The positions of P3 and P4 are marked. Okay, point I. Draw a line joining P3 and P4. بص, joining P3 and P4. Continue the line until it meets normal and L. Label the point H where this line cuts through or meets line CD, and draw the line FH. طيب, واحدة واحدة. Okay. First of all, can I join lines P3 and P4 and continue the line until it reaches NL? Okay, حاضر. Line P3 and P4 until it reaches NL. اهو P3 طبعا using the ruler. Okay, P3 and P4 until, very carefully يا شباب, carefully draw the line until it reaches NL. Okay, until it reaches NL. That's it. Label the point where this line meets CD. Where this line meets CD. Label this point what? Label this point F. Label this point F. طيب اهو F. Label this point sorry, H. I'm sorry. He said H. I'm sorry. He said H. Label this point H. Label this point H. طيب, وبعدين what should I do? He said draw a line and FH. Draw a line FH. Line FH. F. Oh, this is F and this is H. Draw a line FH. Oh. Draw a line FH. بس that's it. خلاص, I took a mark. Just drew two lines, put a point H. I draw another line FH. خلاص. I keep on taking marks. يعني هنا 1 2 3 4 marks, just drawing a couple of lines. And then a couple of other marks just to measure some distances. A, okay, record the length A, which is the line of GH. Can you measure the distance between GH? The distance between G and H? فين? Distance between G and H. Can you measure this distance? Yes, I can measure this distance. What is this distance? I guess if you measure the distance carefully, it would be around 1.8 centimeters. Okay, if you measure the distance carefully, it would be around what? 1.8 centimeters. طب يا مستر, I measured it was 1.9. لا, I measured it was 1.7. طب خلاص 1.7 or 1.9, it would be acceptable. Anything above that would be, no, it wouldn't be acceptable. Okay, if it's above 1.9, if it's 2.1, 2. That's too much. Probably there's something wrong with your drawing. Probably you need to erase the drawing and repeat it again. Okay, your lines, your pencil wasn't thin enough, for example, or your angles were off, or the normal wasn't exactly 90 degrees, or it wasn't exactly at the center. These are some problems while drawing يا شباب. That's why you need to be very careful while drawing. Okay, 1.8 would be a very exact number for the distance GH. طيب, can I find FH? Can I measure FH? Yes, I can. يلا, measuring FH, distance from F to H. Again, it would be around 5.4 centimeters. 5.4. Again, if it's above or below, if it's 5.5, if it's 5.3, ماشي, okay, acceptable. But you can't go much further away than 5.4, 5.5 or less than 5.3, okay? Yo, I have A and I have B, 1.8 and 5.4. Can you calculate the refractive index N? Can I find N using this equation? 0.5 B over A. Okay, I have B and I have A. Yeah, 0.5 B, which is 5.4. So 0.5 times 5.4 over A, which is 1.8. صح? 0.5 times 5.4 over 1.8. N would be N would be 1.5. 1.5. Let's say it's without a unit, okay? It's unitless. N doesn't have unit. Okay, so N 0.5 B over A, خلاص, this is the answer, 1.5. Okay, if you have, again, if N is slightly above or slightly below 1.5, it's okay because your A would be slightly above or below 1.5, 1.8, and B خلاص. But again, 1.5 is it should be the most common answer among your answers. If it's slightly above or below, okay, it could be acceptable. Now the student is repeating the experiment using different values of A and B. A is 3.2, B is 6.9. Can he find the new refractive index? Yes, he can find the new refractive index. 0.71B. 0.71 times 6.9 over 3.2. So this would be very close to 1.5, which would be around 1.53. 1.53. Okay, 1.53. IV was 1.5. 1.5. Okay, all you did was you just plugged in the numbers and you calculated 1.5. Again, هنا you plugged in the new numbers using the new value of B. Okay, using the new value of B and the new value of A. So 0.71 times 6.9 over 3.2, which is 1.53. Type. The student expected the two values of the refractive index in this experiment to be equal. He expected them to be equal. The state two difficulties, على فكرة, they are equal. To be honest, experimentally, they are equal. State two difficulties in this experiment that could explain any difference in the two values of n. In the two values of n. I need some difficulties. You need some You need some difficulties. We can talk about some of the precautions that weren't taken. Some of the precautions that weren't taken. For example, um, you should take sorry, you should draw thin lines. صح? I'm always saying you use thin lines. You make sure that your pencil is sharpened, whatever. So using thin lines, this was a difficulty. If you used thick lines, this is wrong. So you need to use thin lines. Okay, you didn't use thin lines, so this is one of the difficulties. Okay, use thin lines. Use إيش thin lines. Taking the reading perpendicularly, انت you're saying taking the reading perpendicularly, it's not wrong, okay? But for this experiment we say viewing the bases of the pins. Okay, we say ايش view the bases of the pins. So we can write down view the bases of the pins. Difficulties are some of the problems that you could face while conducting this experiment. So some of the problems would be that I didn't view the bases correctly, that I didn't use thin lines. Okay, the pins could be bent. Whatever. We have some difficulties. Okay, a student suggests some of the precautions. Tick one box to indicate the most sensible suggestion. Okay, most sensible suggestion. Uh, Someone's saying viewing the basis of the pins is like it is like taking the reading perpendicularly, but for this experiment we say view the bases of the pins. Can I say the normal has to be 90 degrees? um it's not wrong. Okay, it's not wrong because you can say that you need to draw accurate lines. It could be part of saying accurate lines. Yes, it could be right. It could be right. What is the most sensible suggestion? What is the most sensible precaution out of these four precautions? For this experiment, the most sensible precaution would be viewing the bases of the pins. Okay, this is the most sensible precaution for this experiment. Okay, طيب يلا moving on. Yeah. Question 4. I know you love this question, صح? I love it too. Actually, this question is I can't say it's easy, okay? It is very systematic. What do I mean by systematic? It means that you have a couple of steps, okay? You need to write down 7 steps to take the 7 marks. You can very easily take 5 out of these 7 marks. Very easily take 5 out of these 7 marks. Okay, I told you the 7 steps. Okay, I wrote them down before. We will write them down again today. Um, and then it would be, يعني, inshallah, quite clear for this question. Dati, what is this experiment? How can I plan this experiment? A student is investigating the relationship between the power produced, okay, of a heater, electric heater, and the time taken to heat a beaker of water. Time taken to heat the beaker of water. Power produced by the heater and the time taken to heat a beaker of water. The power can be calculated using this equation: power equals VI. So you have the voltage, you have the current, you can find the power VI. Where V is the potential difference, the voltage, and I is the current in the heater. Plan an experiment. I told you this is the most important statement in this question. Plan an experiment to investigate the relationship between the power produced by an electrical heater and the time taken to heat the beaker of water. Okay, you have some apparatuses: ammeter, voltmeter, variable power supply, 250 centimeter beaker, heater, thermometer, stopwatch. I guess you have all of the apparatuses that you would need for this experiment. Okay, so while reading the points, I don't think he will ask you to write down any additional apparatuses. Why? Because you already have all of the apparatuses that could be needed, that could be required for this experiment. First of all, okay, you need to complete the diagram. Where's the diagram? Oh, it's in the next page. Okay, complete the diagram. Explain, yalla, the steps. State the key variables, the constants, the drawing the table. Okay, and then the conclusion. Okay, we have 7 steps. We will write them down, inshallah. What about this diagram? What is this diagram? This is the heater inside the water. The heater inside the water. What should we do with this heater? Okay, we need to complete the diagram. We need to complete the circuit to take the readings. Look, we need to find the reading of the voltage and we need to find the reading of the current to find it in order to find out to calculate the power. So first of all, we need a voltmeter. صح? We need an ammeter. We need a power source, battery, or whatever. صح؟ طيب, should I add a variable resistor if you want to? طب, should I add a switch? Okay, if you'd like to. It doesn't. Okay, these things don't really matter. What matters, what I care about in this question is what is a voltmeter in parallel. إيه ده يا مستر, this is in series. Wait, just wait. Okay, and then an ammeter in series and a battery or a power source. If you want to add a switch, it's okay. If you don't want to, again, it is okay. I have an open switch, for example. This is an open switch, a battery, an ammeter, and the voltmeter. So the ammeter is in series, the voltmeter is in parallel with the electrical heater. So I'm taking the voltage, the potential difference of the heater. I'm taking the current in the circuit. خلاص, that's it. Okay. Um, it would be quite sensible. It would be quite sensible not to draw the voltmeter down here. This would be, يعني, it wouldn't be wrong, بس يعني would be quite sensible not to draw it here. Why? Because this is water. If you put the voltmeter inside the water, it would blow up. صح? It might electrocute you. So do not just draw the voltmeter هنا. طيب you have voltmeter, the ammeter, the battery, and the power and the switch. طيب we have 7 steps. We need to write them down. I don't think we write them all down because we won't write down the apparatuses, but we can write down most of them. First of all, we have to say what are the range of values. What is the independent variable? What is the independent variable? The independent variable is the power. Independent variable is the power. How can I control the power? How will you be able to control the power? By changing the voltage. By changing the voltage. So the power, to control the power, you will control the voltage. طب يا مستر, this is the battery. Will I keep on changing the battery? Yeah, you can change the battery. Or actually the question, he said that you have a variable power source. What is a variable power source or a variable power supply? A variable power supply, it's like a variable resistor or whatever. You can change the voltage. Instead of it being 1 volt, it could be 2, 3, 4, 5, whatever. So this is the input voltage, صح? Based on which the power will change. طيب يبقى basically you can write down the range of values or the independent variable that you will be changing. It could be either voltage or EMF يعني, or the power. Let me write down the power. For example, this is the range of values. Number one, range of range of values. The power supplied, the power supplied, which is, for example, you have to give 5 inputs, 5 values. If I say 10 watts, 20 watts, 30 watts, 40, and 50 watts. Okay, these are different values for the power. طيب يا مستر, I didn't want to say the power. For example, what if I said the voltage? What if I say the voltage? Can I write down the voltage? Yes, you can write down the voltage. Okay, الفولتج أو input voltage, voltage supplied. What are the different values of the voltage? 2 volts, 4 volts, 6 volts, 8 volts, 10 volts. A range of values. How can I know the ranges? The ranges, and I wrote down 2, 4, 6, 8, 10. I didn't exceed above 10. Why? Because the battery, the maximum voltage of the battery is 12 volts. This is the maximum voltage of the battery. So you can go above 12 volts. Okay, this is the range supplied. This is the range of the values for the voltages, for the input voltage. This is the independent variable. This is the number that I will be changing. Range of values. What about the constants? What about the controlled variables? What are the constants in this question? First of all, you have to begin with the range of values and then the controlled variables. Current is not a constant. Okay, current could change. Current could change. So do not write it down as a constant. Okay, water amount. Yes, the volume of the water. Yes, definitely. Definitely. Yeah. What else? Huh? We could say the initial temperature of the water, the final temperature of the water, the room temperature. These are all constants. These are all a constants. You need to write down the volume of the water. Volume of the water, thickness of the wire. Okay, yeah, you could say so. But these are more important actually. Volume of the water, initial and final temperature. Okay, and final temperature of the water. How, and I will tell you how is the final temperature constant. Okay, initial and final temperature of water, room temperature. This experiment you want to find the time taken. Okay, you want to find the time taken for the water to reach or to increase a certain temperature. For example, if it was 20, and we want to see how long will it take to reach 40 degrees, from 20 degrees to 40 degrees. So the initial temperature is constant and the final temperature is constant. The variable would be the time. The thing that will be changing, the dependent variable would be the time. Okay, dependent variable would be the time, and we are measuring the initial and final temperatures for this question. Okay, يبقى دلوقتي I'm changing the voltage, I'm changing the power supplied. When you change the power supplied, the time taken for the water to heat up would change. Definitely it would decrease. Definitely the time taken would decrease if you increase the power, because it would heat up more quickly. Okay, طيب. Can I write down the apparatuses? I don't need to write down the apparatuses. The next step should be the steps. Okay, what are the steps taken? What are your steps? Well, first of all, we can add the same volume of water. خلاص, we will add the same volume of water, and then we will measure the voltage from the voltmeter and measure the current from the ammeter, and calculate the power using the equation P equals VI. So first of all, measure, okay, the voltage or the potential difference V using the voltmeter, and measure the current I using the ammeter, and then calculate the power using the equation. Using the equation P equals VI. P equals VI. خلاص, that's it. يعني these are the steps. Yes, these are the steps. Should I write down any precautions? Well, if you'd like to write down any precautions, yes. Okay. Using the equation P equals VI, we can say calculate the time. Or use the stopwatch. Use the stopwatch to measure, or to calculate the time taken. To calculate, يلا, the time taken for the water, يلا, for the water to increase by, for the temperature of the water, to be accurate, for the temperature of the water to increase by a certain amount, for the temperature of water to increase, okay, by a certain amount. Should we say increase V and I to have more temperature? Yes, we will say repeat the experiment using different values of V. Yes, this is in the conclusion. We will repeat the experiment using different values of V, and that's why we wrote down the values of V in the range of values. That's why we wrote it down in the range of values. So you have to write down the steps, and يعني write down as much details as you can think of. Whatever details you want to write down in the steps, just write them down. Okay, just write them down. What would happen when we start the experiment? What will happen when you switch on the current? The water will start to heat up. The water has to have an initial temperature. It has to have a constant initial temperature. It will start to heat up. For example, it was 20 degrees Celsius. It will heat up until it reaches 40 degrees Celsius. So we need to calculate the time taken for the water to heat up from 20 to 40 degrees Celsius. And then we need to repeat the experiment using a different voltage input. Okay, repeating the experiment using a different voltage input. These are the steps. Can I write down any precautions? Okay, if you have any precautions, for example, okay, precautions, we can write down reset the stopwatch. Okay, reset the stopwatch. You can also reset الفولتميتر, الاميتر. هنا you have a thermometer. You can say take the reading of a thermometer. Take the reading of a thermometer perpendicularly. Why? To avoid what? To avoid the parallax error. To avoid the parallax error. Okay, to avoid the parallax error. But again, taking the reading perpendicularly to avoid the parallax error. You can say other precautions for the thermometer. You can say stir the water gently to take an average temperature. You can say leave the thermometer for a couple of seconds before taking the reading when you put it in the water. These are all some of the precautions. Okay, these are just some of the precautions that you can write down in this experiment. Okay, so these are the precautions, and then you need to draw a table. You need to draw a table. Can I draw a table? Yes. Where should I draw the table? Wherever you'd like. If you have space, you can. And personally, I prefer to write down the table. I will write the conclusion now. Okay, after I'm done with the table. Personally, I prefer to draw the table in this space. Okay, what should I write down in the table? I only need to write down the table of the column headings. What are the column headings? What are the readings that I will take in this experiment? What are the readings? The voltage, the potential difference. صح. الvoltage. What is the unit of الvoltage? الvoltage V. الcurrent in amperes. الpower. ها الpower in watts. Last but not least, time in seconds. Time will change. Okay, okay. Time in seconds. So voltage, current, power, and time. Should I write down any other? Should I write down anything else in the table? لا. Should I fill the table with any numbers? No. You shouldn't fill the table with any numbers. This is the table that he wants. He just wants to see the column headings, and that's it. That's all you need to do. That's all you need to write in the table. Okay, do not write down any more numbers in the table. Okay, just the table headings. Time for what? Time for the water to heat from the initial temperature to the final temperature, and that's why the initial temperature is constant and the final temperature is also constant. Yeah, range of values, steps. Okay, let me go on and write down the conclusion, which is quite okay. Conclusion. I told you the conclusion is quite systematic. What should we write down in the conclusion? For each value of something, for each value of the independent variable, صح? For each value of the independent variable, which is the voltage. يلا, for each value of the voltage. What should you do? Repeat the experiment. Repeat the experiment and take average. For each value of the voltage, repeat the experiment and take average. And then repeat the experiment and take average. And then record the readings. Record the readings in the table. After you're done with recording tables, you need to compare the results. How can I compare the results? By drawing a graph. يبقى compare the results by drawing a graph. That's it. This is the conclusion. For each value, repeat and take average. And then record these averages that you found in the table, and then compare the results by drawing a graph. Okay? Okay, good.